Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. CrO3 in aqueous H2SO4, Jones-type oxidation, oxidize primary alcohols to carboxylic acids and secondary alcohols to ketones. For decarboxylthione to occur readily on heating, the oxidation product must be a beta-keto acid, a carboxylic acid with a ketone at the beta carbon, i.e., 3-OXO acid, which undergoes facile decarboxylthione via a cyclic 6-membered transition state. Moving on to the next step. Identify what structure gives a beta-keto acid upon oxidation. A diol that, when oxidized by CrO3H2SO4, produces a beta-keto acid must have one primary OH oxidized to Cu and one secondary OH at the beta position oxidized to C is equal to O, i.e., the two OH groups are separated by one carbon, 1,3-diol pattern with appropriate substitution, or one OH is secondary and adjacent positioning gives a beta-keto acid. Actually, the key requirement, oxidation of a 1,3-diol where one OH is primary gives a 3-hydroxy acid intermediate, but further oxidation of the secondary OH in a 1,3-diol gives a beta-keto acid, 3-oxo acid, which decarboxylates readily. Moving on to the next step. I,1,5-pentanediol or similar long-chain primary diol oxidation gives a dicarboxylic acid, deuteric acid type, not a beta-keto acid. Does not readily decarboxylate. 2. A branched diol from the structure, it appears to be 3-methyl-1,3-butanediol or 2-methyl-1,3-propanediol. If it is a 1,3-diol with one primary and one tertiary OH, oxidation gives a beta-keto acid, the tertiary OH becomes a ketone, primary OH becomes Cu, giving a 3-OXO acid. Beta-keto acids decarboxylate readily on heating. This qualifies. 3,1,2-butanediol. Vicinal diol oxidation gives an alpha-keto acid, 2-OXO acid, not a beta-keto acid. Alpha-keto acids do not decarboxylate as readily under simple heating conditions, they require different conditions. Does not qualify. 4. From the structure, appears to be a 1,3-diol with secondary of one OH is secondary, becomes ketone on oxidation, and one is primary, becomes Cu, with beta relationship, giving a beta-keto acid that readily decarboxylates. This qualifies. And for the final step. A. I and 2 compound I gives a dicarboxylic acid, not a beta-keto acid, so it does not readily decarboxylate. Eliminated. B. 2 and 3 compound 3 gives an alpha-keto acid, not suitable. Eliminated. D. I and 4 compound I does not give a beta-keto acid. Eliminated. Only compounds 2 and 4 produce beta-keto acids upon oxidation with CrO3H2SO4, and these beta-keto acids readily undergo decarboxylthione on heating. Therefore, the correct answer is C. Therefore, the correct answer is option C.